Good morning, student. Today we are going to learn about semiconductor memories. After the completion of today's session, you are able to classify different semiconductor memories, draw the diagram of DRAM, and explain the operation of DRAM. So first we discuss about the classification of semiconductor memories. So, semiconductor memories are classified into two types, that is RAM and ROM, random access memory and read only memory. In RAM, stored data is volatile, that is, the stored data is lost when the power supply voltage is turned off. Based on the operation type of individual data storage cells, RAMs are classified into two main categories, that is DRAM and SRAM, means dynamic RAM and static RAM. The DRAM cell consists of a capacitor to store binary information, that is 1 or 0, or we can say high voltage or low voltage, and a transistor to access the capacitor. Here, the cell information is degraded mostly due to the junction leakage current at the storage node. Therefore, the cell data must be read and rewritten periodically, means refresh operation is used, even when memory arrays are not accessed. Then, the SRAM cell consists of a latch. Therefore, the cell data is kept as long as the power is turned on and refresh operation is not required. Due to the advantage of low cost and high density, DRAM is mostly used for the main memory and SRAM is used for the cache memory. Okay, means it is used as main memory and it is used as cache memory. Okay, next, ROM. ROMs are non-volatile memories, that is, the stored data is not lost even when the power supply is off, and refresh operation is not required here. Depending on the type of data storage method, ROMs are categorized as mask ROM, then programmable ROM, then flash memory, then ferroelectric RAM. Okay, so mask memory, in which data are written during chip fabrication by using a photo mask technique. Next one is the programmable ROM. Programmable ROM, in which data are written electrically after the chip is fabricated. Then, depending on data erasing characteristic, programmable ROMs are further classified into two types, that is erasable PROM and electrically erasable PROM. In EPROM, means erasable PROM, UV rays are used to erase the data, but in electrically erasable PROM, high electrical voltage is used to erase the data. Next one is the flash memory. Flash memory is similar to EEPROM. And last one is the ferroelectric RAM. Ferroelectric RAM utilizes the hysteresis characteristics of ferroelectric capacitor to overcome the slow write of other EEPROMs. Okay, so this is all about classification. Next, in this class, we mainly discuss about the DRAM. Okay, So let's go to the diagram. So this one is the 3 transistor dynamic RAM diagram. So here in this diagram, M1 and M3 are used as access transistor, and the binary information is stored in the form of charge in the parasitic node capacitance C1. Okay. Then the storage transistor M2 is turned on or off depending on the charge stored in C1. This one is the storage transistor M2, and its on and off depends on the charge stored in C1. Okay, charge stored in C1. And M1 and M3 are act as access switch for data read and data write operation. Okay, M1 and M3 are act as access switch. Then the operation of 3 transistor DRAM cell is based on 2 phase non-overlapping clock scheme. Means here the operation is done in 2 phases, that is denoted as phi 1 and phi 2. Okay. So in phi 1 phase, pre-charge event is occur, or we can say the pre-charge events are driven by phi 1, whereas the read and write events are driven by phi 2. Okay. Every data read and write operation is preceded by the pre-charge cycle. Means before data read or write cycle, we have to do the pre-charge operation. Okay, which is initiated with the pre-charge signal PC. So this one is the PC. Means we have to make it high. Okay, initiated with the pre-charge signal PC going high. During the pre-charge cycle, the column pull-up transistors are activated. Let's go to the next diagram. This one is for pre-charge operation. Here the column pull-up transistor, these are column pull-up transistors, are activated, and the corresponding column capacitance, that is C2 and C3. In the previous diagram, here you can see C2 and C3 are column capacitance, and these are the column pull-up transistors. Okay. So capacitance C2 and C3 are charged up to the logic high level. Okay. This is only the operation of pre-charge. Okay. Next we discuss about the write 1 operation. So let's go to the main diagram. Here you can see 2 lines are present. One is RS, other one is WS. WS means write select and RS means read select. As per our operation, we activate the line. If we are doing the write operation, then we activate the WS line. If we are doing the read operation, then we activate the RS line. Okay. So first here we do the operation, that is write operation. For that we activate the WS line. If WS line is activated, then the transistor connected to this WS line is activated. So in write 1 operation, M1 is in on condition, M3 is in off condition. Okay, and C2 is fully charged. So the diagram looks like this. Okay, WS line is activated, RS equal to 0 means inactivated, then C2 fully charged and M1 turned on. So when M1 is turned on, at that time C2 is in high value but C1 is having 0 value. So what happened? Due to the potential difference, the C2 starts to discharge. So this process is known as charge sharing process. and this charge sharing process interpreted as write 1 operation. Why? Because due to charge sharing, after some time here the voltage reaches to high level, means 1. So this operation is known as write 1 operation. And also remember that for turning on, it absorbs VTN voltage, and during pre-charge operation C2 charge to VDD. So at this point, after some voltage drop, we get VDD minus VTN. Okay, so this one is the voltage present at this node. Next is the read 1 operation. So for read 1 operation, first we do the pre-charge operation, then we activate the RS line. By activating the RS line, see here, by activating the RS line, the transistor connected to this line, that is M3, is turned on. And in the previous operation during write 1, the C1 have high voltage. Because of high voltage, M2 is also turned on, because C1 is connected to the gate of the M2. Due to the high voltage, it makes on the M2. So this one is the diagram for read 1 operation. So in read 1 operation, RS line is activated, because of that M3 is on, and during write 1 operation, C1 having logic high level voltage, so because of that M2 is also turned on. And here the C3 having high voltage, that is equal to VDD during pre-charge operation. So in read 1 operation, what happened? The C3 starts to discharge through this path, or we can say M2 and M3 creates a conducting path between data read column capacitance, means this one, column capacitance C3, and the ground. So in this way it starts to discharge. The capacitance C3 discharges through M2 and M3, and the falling column voltage, means decrease in column voltage, is interpreted by the data read circuitry as stored logic 1, means it read logic 1. Okay, next is the write 0 operation. As it is a write operation, that means WS line will be activated, and due to the activation of WS line, the M1 automatically turned on. So for the write 0 operation, the inverse data input, this one, the inverse data input is at the logic high level, means 1 is given here, because the data to be written onto the DRAM cell is a logic 0. So due to this 1 is given at the input, here logic 0 is present, or we get the logic 0 value here. The write select signal is pulled high during the active phase of phi 2, means this line is activated. As a result, the write access transistor M1 is turned on. The voltage level on C2 as well as that on the storage node C1 is pulled to logic 0 through M1. Okay, see here the arrow mark is given. So C1 and C2 will be discharged, okay, and pulled, or we can say decreased to logic 0 through M1 and the data write transistor. Okay, means it connect the C1 and C2 through M1 to ground. Okay, next, thus at the end of the write 0 sequence, the storage capacitance C1 contains a very low charge and the transistor M2 is turned off. As we know, due to logic high value of C1, M2 turned on. So when C1 discharged to logic 0 voltage, then M2 automatically turned off. Okay. So this is interpreted as write 0 operation. Next one is the read 0 operation. In order to read this stored 0, means in previous operation we write 0 in this DRAM. So in order to read that 0 that is stored in this DRAM, the read select line, that is RS line, must be pulled high or activated during the active phase of phi 2. As we know, in phi 2 phase, data read and data write operations are occur. Okay, following the pre-charge cycle. So the read access transistor M3 turned on, but since M2 is off, means as there is no charge present in C1, due to that the M2 is in off condition. There is no conducting path between the column capacitance C3 and ground. Means during pre-charge phase, means just before the read 0 operation we do the pre-charge operation. In pre-charge operation C3 is fully charged, but due to M2 is turned off condition, there is no path present between C3 and ground. So C3 does not discharge, and the logic high level on the D out column, means this column, is interpreted by the data read circuitry as a stored 0 bit. So this is all about read 0 operation. So this is all for today's class. Thank you.